Angles are important concepts for the Praxis Core Math exam. This quick video will review definitions and how angles might be used on the exam. Let's define the different types of angles. The first is an acute angle. They measure between 0 and 90 degrees. You can remember this name by the word cute, as this is the littlest angle and little things are cute. The next is a right angle. Right angles are exactly 90 degrees. You can see this is indicated by a perfect square. You might see this indication in some triangles and quadrilaterals. Identifying a right angle will be important in solving problems. The next angle is an obtuse angle. This angle is between 90 and 180 degrees. The last angle is technically a line, but we call this a straight angle. It is exactly 180 degrees. As a side note, triangles are exactly 180 degrees as well. All of their angles will add up to 180. Circles are 360 degrees, which you've probably heard in everyday conversation. When solving for angles on the Praxis, a set may be a complementary pair or a supplementary pair. A complementary pair adds to exactly 90 degrees. We can see between these two lines, there's a perfect right angle. There's just a line separating the two. If this side were 60, for example, and this side was x, we could set the entire thing equal to 90 degrees and solve for x. X plus 60 equals 90. Subtract 60 from both sides to isolate x, and x equals 30. A supplementary pair adds up to exactly 180 degrees. It looks like a straight line here, and then there's another line cutting through it. If this side were 120 degrees and this side was x, we could set this equal to 180 to solve for x. X plus 120 equals 180. Subtract 120 from both sides to isolate x to get x equals 60. There are two main relationships between lines. These are parallel They are exact copies of each other, and they will never touch. The exact opposite of parallel lines are perpendicular lines. These lines have nothing in common. One is running up and down, while another is running left and right. Here, they create two right angles. This unique set is called a parallel cut by a transversal. These are parallel. And the test will mention these specifically by name. If they don't, then this relationship doesn't work. This specific set of circumstances creates identical angle measurements at all intersections. A question may only give 1 degree value, and you can solve for every angle found here. There are several relationships you can explore. First, we could call this a supplementary set. Let's call this X and solve. X plus 130 equals 180. Subtract 130 from both sides to isolate X, and X equals 50. We can put 50 here. Another rule is that opposite angles are the same. So if this is 130, then this is 130 as well. This will also be 50. You can also see that if we added all of these values together here, we would get 360 degrees, or a circle. That's another way to solve. Finally, because this line and this line are parallel and exact copies, whatever angles are over here will be the same measurements over here. We can copy these angles to the other line. With just one value, we were able to solve for all measurements. Most angle questions will ask to solve the measurement of an angle like this. What is the value of x? It feels like we have no information, but we do have this drawing of a square. A square angle is a right angle, and a right angle is 90 degrees. There are several options to solve. The quickest is to say that opposite angles are the same. So if this is 90, then x must be 90 as well. We could use a supplementary set to solve all the way around. We could say 90 plus, and call this y, 90 plus y equals 180. And we can solve for y. Then we can solve, once we know what y is, we can set y plus x equals 180. We could also set the entire group to be 360 degrees. So x plus 2y plus 90 equals 360. No matter what procedure you use, 90 will be the answer. Choice B.